A radar system emits short bursts of radio wave using an antenna. These waves travel through the air at the speed of light. When they hit an object, some of them bounce back towards the radar. The radar antenna receives the reflected wave called echo. The system calculates the time delay between sending and receiving pulse to determine the object distance. And the frequency shift help measure the speed of object. And its size depend on how much energy is reflected back. The radar processes this data and display it on a screen, showing the position, speed, and sometimes the object type. Radar used for many purposes like weather forecasting, air traffic control, military air defense, speed detection, and even self-driving car. For example, if a radar used for weather forecasting, the radar sent an electric waves traveling at the speed of a light. When this pulse hit a water particle, they reflected back to the radar. How long the pulse takes to return to the radar determine the distance from the radar, and the strength of the return determine the type of precipitation. And if a radar used for air defense system, it plays a crucial role in detecting and tracking unknown aircraft or incoming missile in a real time. The radar scans the sky, and when threat is detected, the data is displayed on a monitor for defense operator. Depending on the system and missile type, there are three ways the response can happen. Manual. A human operator decides whether to launch a missile. Semi-automatic. The system recommends action, but final approval is still human controlled. Automatic. In high-speed threat like ballistic missile attack, the system can auto-launch without human input. Once a missile is launched, modern systems rely on a combination of onboard radar, infrared sensor, and GPS guideline. This allows the missile to lock on the target, continuously adjust its flight path, and precisely strike or destroy the object.